Hello class, this is lesson 9.3, Properties of Rectangles, Rhombuses, and Squares. In this lesson, we are going to be talking about these different quadrilaterals. In the previous lessons, we focused on parallelograms, but then we need to look at the properties of these quadrilaterals. So to start, we're going to actually talk about rectangles. What is a rectangle? If you look at the definition of a rectangle is a quadrilateral with 4 right angles. So you can see that there are 4 right angles in this quadrilateral. And then the properties of rectangles. So if a quadrilateral is a rectangle, then it is also a parallelogram. Because these are right angles, these lines are parallel to each other, and these lines are also parallel to each other, which would make this a parallelogram. Next, if a parallelogram is a rectangle, then its diagonals are congruent. So in the previous lesson, we talked about diagonals is the distance between 2 angles. So the diagonal would be AC and then BD. So what they're telling us is that if this is a rectangle, then this diagonal is equal to this diagonal. Okay, so they give us proofs. I would suggest to look at the proofs, see if you could follow the proofs. But I think what's more important is how do we solve problems with rectangles, and that's on the next page. So we're actually going to be skipping this part. So these come from the definition from the previous page. But what I wanted you to do is go to page 29. So let me focus on the problem. Okay. So the directions. Find each measure using the rectangle below to help you. So here's our rectangle, and we know some things. The first thing that we know is that AD is equal to 7.5 centimeters. So this is 7.5. DC is 10 centimeters, so this is 10 centimeters. And they want us to find out what DB is. They want us to find out this length. One thing that we could do is, using the properties of a parallelogram, if this side is 7.5, then this side is also 7.5. If this side is 10, then this side is also 10. Now, in this rectangle, let me focus on this right triangle. So this right triangle, BCD. And then let me draw that right triangle out here. So this is BCD. This side is 7.5 and this side is 10. And we want to find out this length. So I'll call that X. Because we're dealing with right triangles or right angles, we could use the Pythagorean theorem to find the missing side of a right triangle. So remember that a squared and b squared are the legs of the right triangle, and C is the hypotenuse. So using that formula, I would have 7.5 squared plus 10 squared is equal to x squared. So 7.5 squared is 56.25. 10 squared is 100. And 56.25 plus 100 is 156.25 equals x squared. To solve for x, we need to take the square root of both sides. And I get x is equal to 12.5. So because we set x as the distance between B and D, this is what BD is equal to. BD is equal to 12.5 centimeters. So let's try this problem again, but with different dimensions. So let's start by just drawing this rectangle as it is. So we have A, B, C, D, and then we have a diagonal and a diagonal. And then we know these are right angles. Okay. So the first thing that they tell us is that AB is 17 and BC is 12.75. And they want us to find out what DB is. They want us to find this length. So if you guys want to pause the video here and attempt this problem on your own, and then when you guys click play again, you guys could see the solution. So if this side is 17, this side is also 17. If this side is 12.75, then this side is 12.75. And what we form is a right triangle. So BCD. So let me draw that right triangle. So this is B, C, and D. This is 12.75. This is 17. And this is going to be our x. Then using the Pythagorean theorem, I'm going to have 12.75 squared plus 17 squared is equal to x squared. So 12.75 squared becomes 162.6. 17 squared is 289. And 289 plus 162.6 is 451.6 equals x squared. And then we take the square root of both sides. And we get x is equal to 21.3 rounded. And that would be centimeters. So what that means is that dB is equal to 21.3 centimeters. So the reason why we're able to use the Pythagorean theorem for rectangles is mainly because we know that rectangles form right angles. And if you look at a diagonal of a rectangle, you actually form two right triangles, and you're able to find a missing side with the Pythagorean theorem. So the Pythagorean theorem should be a review for you guys. This should be what is new and how we apply the Pythagorean theorem. Okay, so then let's move on to the next quadrilateral. Okay, so the next quadrilateral is a rhombus. Now, a rhombus, let me read the definition. A rhombus is a quadrilateral with four congruent sides. So the thing that we know about rhombuses is that each side is congruent to each other. And here are some properties of rhombuses. If a quadrilateral is a rhombus, then it is also a parallelogram. So what that tells us is that these sides are parallel and these sides are parallel. This is a parallelogram. If a parallelogram is a rhombus, then its diagonals are perpendicular. Now this is important, and what that means is that if I was to draw diagonals, the diagonals are perpendicular. So what that means is they form right angles in the middle. And the last thing is, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So what that means is that these diagonals actually cut the angle in half. So let's say that angle M was 100 degrees. Half of that would be 50. So each angle would be 50. And we'll talk about that a little later. So we have a proofs here, but then we're going to actually jump to some practical problems. And then in your notes, if you guys want to draw a rhombus and write definitions in your own words, you guys are free to do that. And then if you guys want to use this as a study guide of what are the properties of rhombuses, the three properties that we just talked about, you could do that as well there. Okay, so let's talk about these examples. Now these examples are already completed for us, but I just want to walk you through the steps. The first thing is that we have a rhombus, VWXY. Okay, we know VW is 6m minus 12, Wx is 4m plus 4, and then we know that this angle here is 3n squared minus 0.75. The first thing they want us to do is find the distance of xy. So remembering the properties of a rhombus, all sides are equal to each other. So if this side is 5, this is 5, this is 5, and this is 5. Knowing that each side is equal to each other, we could say that VW is equal to Wx. So VW equals Wx. Then if we substitute the values for VW and WX. 6m minus 12 is equal to 4m plus 4. Doing some algebra, so subtracting 4m to this side, adding 12 to this side, and dividing, we get m is equal to 8. Now that you know what m is, you could plug it in into one of these sides. And so what they did was they plugged it in for m here. 6 times 8 minus 12 is 36. So if this side is 36, then this side has to be 36 as well, because these sides are all congruent to each other. Okay, and then for our second problem, they want us to find angle YVW. So angle YVW. Now, angle YVW is this combined angle. And remember that diagonals in a rhombus bisect the angle. So if we know what this angle is, that also gives us this angle. And then we could find the combined angle. To start off, what we do, or what we're saying, is that the diagonals of a rhombus are perpendicular. So remember that perpendicular means that they form right angles. And knowing that, I could set this angle, 3n squared minus 0.75, equal to 90 degrees. And that's what they did right here. So, to get from this step to this step, I'm going to kind of show you on the side here. So they had 3n squared minus 0.75 equals 90. The first thing they did was they added 0.75 to both sides. And you're left with 3n squared is equal to 90.75. Next, they divided everything by 3. And 90.75 divided by 3 is 30.25. And last, they took the square root of both sides. And that's how they got n equals 5.5. So, n is important in this problem because once we find out what n is, you could plug it in here to get this half of the angle and then double it to get the rest. And that's what they did. So actually they didn't show it, but let's actually do it together. So the measure of angle WVZ is equal to 9 times 5.5 plus 4. Which gives us 53.5. So if this angle is 53.5, then this is also 53.5. And what they did was they doubled, or they multiplied by 2, and they got 107 degrees. So this combined angle is 107 degrees. So using the same figure, we're actually going to be doing 2 more problems on the next page. So for number 1, they want us to find the measure of angle VYX. So the first thing we need to do is we need to identify where angle VYX is located. So here's VYX, that is this angle. Now, going back to the previous problem, we found this angle was 107 degrees. So let me draw that here. If this angle